100,000 years ago, we were almost gone. Not a civilization, not a kingdom, a handful of fires scattered across a dying continent. The predators were larger, the climate was breaking, entire bloodlines simply ended. And somewhere in the dark, a small group kept moving. They had no writing, no cities, no certainty they would see the next season. They had each other. 100,000 years of survival, adaptation, and a world that wanted us extinct. Most human lineages from this era vanished. Only ours made it to the end. This is where that story begins. "100,000 years ago, the human species almost ceased to exist. Populations across Africa collapsed. Entire bloodlines simply ended. The genetic evidence buried inside every living person today points to a moment so severe, so prolonged, that the number of breeding adults on the entire planet may have dropped below 10,000 individuals. Some estimates go lower. We were not the dominant species. We were not the apex predator. We were prey, scattered across a hostile world running out of time. If you want to understand where humanity actually comes from, not the polished version taught in classrooms, but the raw, brutal, barely survived version, hit subscribe right now. Every week, we go to the places and the moments that textbooks skip. This is one of those moments. The world, 100,000 years ago, looked familiar from a distance. Continents sat roughly where they do today. Oceans filled the same basins. Sunrises happened every morning. But the climate was doing something our brains are not built to truly understand. Cycling between extremes across timescales longer than entire civilizations. Ice ages ground across the northern latitudes. Interglacial periods warmed the planet, and then, without warning on any human timescale, the cold returned. Forests became grasslands, grasslands became desert. Rivers that fed entire ecosystems for 10,000 years dried up within a few generations. The animals adapted, or they died. Homo sapiens, barely 100,000 years into their existence as a distinct species, had to do the same. And here is what almost nobody talks about. They nearly failed. Our species emerged in Africa, almost certainly in the northeastern or eastern regions, somewhere between 200,000 and 300,000 years ago. But emergence and survival are two completely different things. For the first 100 millennia of human existence, populations remained extraordinarily small. Small enough that a single prolonged drought, a single volcanic winter, a single collapse in the game herds that groups depended on could wipe out an entire lineage. That is not a metaphor. Genetic studies have found that modern humans carry the signature of extreme population bottlenecks, moments when the number of ancestors who successfully reproduced dropped so dramatically that almost all genetic diversity was erased. The diversity we see in humans today across every continent, every culture, every face, emerged from a pool of survivors so small it is genuinely difficult to comprehend. At 100,000 years ago, that bottleneck was either already happening or approaching fast. Picture the landscape of Eastern Africa during this period. The Rift Valley stretched across the continent like a wound. a series of lakes, escarpments, and narrow corridors that funneled both animals and people. When the climate was favorable, those lakes expanded and the surrounding ecosystems exploded with life. Hippos wallowed in waters that now sit in the middle of desert. Grasslands stretched for thousands of kilometers, supporting herds of animals that would dwarf anything living on the continent today. Giant buffalo with horns spanning over 2 meters, elephants with shoulders taller than a modern African elephant, saber-toothed predators that still prowled the fringes of the savanna. And in the middle of all of it, small bands of Homo sapiens, probably numbering between 20 and 50 individuals per group, trying to find enough food to keep everyone alive through another season. When the rains failed, everything collapsed at once. Water was the organizing principle of survival. Every group tracked it. Every migration followed it. When a reliable water source dried up, a group had to move. And moving across unfamiliar territory in a world full of large predators was one of the most dangerous things a human being could do. The predators of this period were not the diminished fauna of today. Lions roamed in forms larger and more aggressive than any surviving population. Leopards competed for the same prey humans hunted. Hyenas moved in clans large enough to overwhelm a human group that was already weakened by hunger. And then there were the ambush predators near the water. The crocodilians that had not yet been pressured by centuries of human hunting. Enormous animals waiting at every river crossing, every lake shore, every flooded plain that people had to cross to find food. A child separated from the group at dusk did not survive. But the predators were not the central problem. The central problem was food, and specifically the gap between what a group needed to eat every day and what the landscape could actually provide. A band of 30 people required an enormous territory to sustain themselves through hunting and gathering. Estimates based on modern forager populations and ecological carrying capacity suggest that each individual needed access to somewhere between 10 and 50 square kilometers of productive habitat. Multiply that across even a small group, and you get a territory that extended further than a person could walk in several days. When neighboring groups were pushed by the same drought into the same shrinking resource patch, conflict was nearly inevitable. And conflict between small groups, where every adult male capable of hunting and defense was irreplaceable, could be catastrophic. Lose 3 or 4 people in a single confrontation and the group might not recover. Lose the knowledge held by a single elder, and the group might lose the ability to process a particular food source, navigate a particular terrain, or perform a particular medical treatment that no one else had learned. Human knowledge at this point lived entirely inside human heads. There were no books, there was no writing, there was no external storage of any kind. Everything a group knew about the world, which plants were edible and which were deadly, which rock formations contained water and dry seasons, which animal behaviors signaled danger, which medicinal plants could treat an infected wound, lived only in the minds of the people who had learned it. An elderly woman who had survived 4 droughts held survival knowledge that could not be replaced. When she died, that knowledge died with her. This is why researchers who study forager societies consistently find that elder mortality during resource crises is not just a humanitarian tragedy. It is an informational catastrophe. Groups that lost their most experienced members during the worst periods of environmental stress were often left without the accumulated knowledge needed to survive those same conditions. The cruelest famines took the very people who knew how to end them. Drop a comment right now and tell us where you are watching from. People from over 80 countries have followed this channel, and it constantly amazes us. If you are finding this valuable and you have not subscribed yet, do it now. The next video is already in production, and it covers a period even more extreme than this one. 100,000 years ago, the human toolset was already sophisticated by the standards of what had come before. Middle Stone Age technology included hafted spear points, blades made from carefully selected stone, and evidence of heat treatment to improve the quality of flint before knapping. This was not primitive improvisation. Producing a well-made hafted point required planning ahead, transporting raw materials over long distances, controlling fire precisely enough to alter stone properties, and executing a series of highly specific physical steps in the correct sequence. The cognitive capacity required for that level of production was not meaningfully different from what a modern person brings to building a piece of furniture or repairing a mechanical device. But sophisticated tools did not guarantee survival. They improved the odds. They did not eliminate the underlying vulnerability. The groups that did survive this period shared several characteristics that show up consistently in the archaeological record. They moved. Mobility was not a failure to settle. It was a survival strategy executed with precision. Seasonal migrations tracked animal herds and fruiting cycles across landscapes that could shift dramatically from year to year. A group that committed too deeply to a single location, that built too permanent a camp or relied too heavily on a single resource, was the group that got caught when conditions changed. Flexibility was the adaptation, the willingness to abandon a place, to leave behind everything that could not be carried, to walk into unfamiliar territory because the familiar territory had become a death trap. That psychological capacity, the ability to let go of a home and move, may be one of the most important evolutionary inheritances modern humans carry. We still feel the pull of familiar places even when staying is the wrong choice. The coastal regions of southern Africa tell a particularly important part of this story. The period between 160,000 and 70,000 years ago saw a cluster of human populations along the southern African coast that show some of the earliest evidence of complex symbolic behavior. Long-distance trade in marine shells, ochre used for purposes that went beyond simple pigment, and exploitation of marine resources including shellfish, fish, and marine mammals. The coast was different from the interior, more stable in terms of water access, richer in calories per unit area than equivalent inland territory during drought periods. The ocean did not dry up. The shellfish beds did not fail the same way that inland game herds could fail. And the coastal people were eating a diet consistently rich in the fatty acids that neurological development requires. There is a reasonable argument that the coast is where the brain got the fuel it needed to build modern cognition. But the coast was not safe either. Storms, rogue waves, the same predators that hunted along riverbanks hunted along shorelines. Great white sharks patrolled waters where people waited for shellfish, and the coast was linear, a single resource corridor with no redundancy. If a population along that corridor grew too large, or if a disease moved through it, there was nowhere to go except along the same line, potentially into the territory of another group doing exactly the same thing for exactly the same reasons. The question that has occupied researchers for decades is precisely when and why and how Homo sapiens started leaving Africa. The evidence now suggests that the timeline was not a single event but a series of expansions and contractions, some of which may have occurred as early as 120,000 years ago, sending small populations into the Arabian Peninsula and the Levant before those populations either died out or retreated when conditions deteriorated. The Arabian Peninsula at periods of higher rainfall was not the desert it is today. Rivers crossed it, lakes dotted its interior, grasslands supported animals. A human group following those resources northward from the Horn of Africa could have pushed deep into Arabia without ever crossing a significant barrier, following the same logic that governed every other migration. Track the water, follow the food, avoid the competition. And then the rains stopped. The lakes dried. The rivers shrank to seasonal trickles. What happened to those early populations in Arabia and the Levant is one of the genuinely open questions of paleoanthropology. The genetic evidence suggests that most modern non-African populations descend from a later, more successful expansion that probably occurred around 60 to 70,000 years ago. If earlier populations made it out of Africa, they left very little genetic trace in living humans. Either they were absorbed into other populations, or they died before they could establish the kind of persistent, growing communities that leave descendants across the millennia. Out there in the desert that Arabia has since become, somewhere beneath the sand and the petroleum geology, are probably the bones of people who walked out of Africa 100,000 years ago and did not make it. We will likely never find them. Back inside Africa, the pressure on surviving populations was intensifying. The period between 90,000 and 70,000 years ago corresponds to a global climate deterioration linked to a combination of factors, including the Toba supervolcanic eruption approximately 74,000 years ago in what is now Sumatra. Toba was not the largest volcanic eruption in Earth's history, but it was the largest in the last 2 million years, ejecting somewhere between 2,000 and 3,000 cubic kilometers of material into the atmosphere. The resulting volcanic winter, a period of global cooling and dramatically reduced sunlight lasting somewhere between 6 and 10 years, would have collapsed growing seasons across wide swaths of the planet. The forests of Africa that human populations depended on would have experienced catastrophic die-offs. The grasslands that supported game herds would have contracted severely, and the bottleneck in human genetic diversity reaches its most extreme expression in the period immediately following Toba. The timing is not coincidental. Whether Toba was the primary driver of the bottleneck or a final catastrophic blow to populations already stressed by the preceding climate deterioration is still actively debated. What is not debated is the outcome. The human population of the world at its lowest point during this period may have been smaller than the current population of a single mid-sized city. Every person alive today descended from the survivors of that collapse, from the groups that had the right combination of location, knowledge, group cohesion, and sheer chance to make it through. That is not poetic framing. That is what the genetics show. So, what did survival actually look like on the ground? For a group of 30 people camped near a drying lake in eastern Africa roughly 100,000 years ago, the daily calculus was relentless. Men and adolescent boys were probably hunting in rotating teams, pursuing medium-sized game that could still be found near the remaining water sources, while avoiding the large predators that competed for the same prey. Women were almost certainly covering more distance than any other group member, moving through familiar and unfamiliar territory to gather plant foods, monitor fruiting cycles, locate hidden water sources, and carry food and water back to a central camp where children, elderly, and injured members of the group remained. The division of labor was not about status. It was about maximizing coverage of the available landscape. Fire was the anchor of camp life, not just for warmth or cooking, but as a psychological center, a signal to other members of the group about where home was at the end of a day's foraging, a deterrent to predators during the hours of darkness when human vision failed completely, and the balance of power between prey and predator tilted sharply toward the cats and the hyenas. Maintaining fire required someone to attend it continuously. It required dry fuel even in wet seasons, and wet season alternatives in dry seasons. It required a body of knowledge about ignition and sustenance that, like everything else, lived in human memory and had to be transmitted to the next generation before it was lost. A group that let its fire die on a cold, predator-thick night had a serious problem. The social bonds inside these groups were the other survival infrastructure that leaves no direct physical trace in the archaeological record, but shows up everywhere in the behavioral evidence. Humans are not the strongest animals, not the fastest, not the best equipped with natural weapons. The adaptation that made the species viable was collective action, the ability to coordinate, to share food across individuals who had not personally acquired it, to care for the injured and the elderly beyond any point of immediate utility, to invest in offspring for the extended developmental period that human children require. An infant is helpless for longer than the infant of any other primate. A human child requires active provisioning and protection for years before it can contribute anything to group survival. That enormous investment only makes biological sense in a context of deep social reciprocity, where the group carries individuals through periods of dependency because everyone benefits from the network of skills and knowledge those individuals will eventually contribute. Humans evolved to need each other in a way that is genuinely unusual even among social animals. Tell us in the comments, if you were placed into this world with no technology, no training, and no group, where in Africa do you think you would last the longest? Coast, Rift Valley lakes, forest edge, open savanna? We read every comment, and the discussions that happen there are genuinely some of the best on the platform. The evidence from burial sites, ochre use, and shell ornaments that begins appearing in the archaeological record around this period says something important about the internal life of these groups. The ochre is the most striking piece of it. Red ochre, iron oxide ground into powder and mixed with animal fat or plant compounds, was being collected, processed, and used by populations across southern and eastern Africa well before 100,000 years ago. Some of it was clearly functional. Ochre has antimicrobial properties and was probably used to treat animal hides, but some of the ochre use, particularly the engraved geometric patterns found on ochre pieces at sites like Blombos Cave in South Africa, goes well beyond functional application. Someone was making marks for reasons that were not directly utilitarian. Someone was encoding meaning into a physical object and presumably communicating that meaning to other people in the group. That is the beginning of something that would eventually become every symbol, every alphabet, every painting, every flag in human history. But it also means something more immediate and more relevant to the survival question. Groups that could encode and transmit information symbolically had a significant advantage over groups that could not. A pattern scratched into a piece of ochre could represent a place, a route, a resource, a warning, a social distinction, a story. Information that would otherwise exist only in a single human mind could be externalized, shared, and potentially preserved beyond the death of the individual who originally held it. The earliest symbolic behavior may have been, at its functional core, a response to the problem of information fragility that killed groups whenever it killed the wrong elder. Symbols are memory that survives the person who made them. The interactions between human groups during this period were complicated in ways that are difficult to reconstruct, but that the genetics partially reveal. Neighboring groups were not simply competitors for the same resources, though they were that. They were also potential allies, trading partners, and sources of mates. A group that maintained exclusively hostile relationships with every neighbor was a group that could not exchange mates across groups, which in small populations leads rapidly to the genetic problems associated with inbreeding. A group that could negotiate access to the territory of a neighboring group during resource failures had redundancy that a completely isolated group did not have. The social sophistication required to maintain those intergroup relationships while also competing for the same resources was not simple. It required the ability to track complex social obligations over long time periods, to remember who had helped your group during the last drought and who had blocked access to a water source, to distinguish between neighbors who could be approached and neighbors who could not. That tracking required language capable of conveying nuance, social categories, and historical context. The pressure to be socially intelligent was in this period almost literally the pressure to survive. There were also encounters, and this is one of the most extraordinary aspects of this period with other human species. 100,000 years ago, Homo sapiens were not alone. Neanderthals held Europe and much of Western Asia, populations that were fully human in every meaningful sense, except that their lineage had separated from ours perhaps 400,000 years before. Denisovans ranged across Asia, a population so recently discovered that researchers are still mapping their distribution and their characteristics. And in Africa itself, there is growing evidence that archaic human populations persisted alongside early Homo sapiens. Populations that had diverged from the main sapiens lineage at various points and maintained separate identities for extended periods before eventually merging with or being replaced by fully modern populations. The encounters between these groups, when they happened, were evidently sometimes violent and sometimes not. The genetic signature of interbreeding is clear. Modern humans outside of Africa carry between 1 and 4% Neanderthal DNA. Some populations in Asia and Oceania carry significant portions of Denisovan ancestry. The mixing happened. People from different lineages had children together, and those children sometimes survived and had children of their own. But the encounters also left evidence of conflict, sites where multiple individuals show signs of violent trauma, populations that expanded into territories previously occupied by other human forms and coincided with the disappearance of those populations from the fossil record. The story of who was where and what happened when they met is still being written. What the period around 100,000 years ago reveals, in aggregate, is a species in genuine existential jeopardy. The climate was actively hostile. The predator community was fully intact and operating at its pre-human expansion intensity. The resources that populations depended on were contracting. The population was small enough that local extinctions, the complete disappearance of human presence from particular regions, were happening regularly. Groups that had occupied particular territories for generations simply vanished from the archaeological record. The fires went out, the tools stopped being made, the ochre stopped being worked, and then, sometimes thousands of years later, a new group moved into the same territory, and the record started again, fresh, with no continuity to what had come before. Those gaps in the record are the silences where entire communities of people ended. And yet, the species did not end. Something in the combination of behavioral flexibility, social complexity, symbolic communication, and ecological mobility was enough, barely enough, across enough of the population to get a sufficient number of people through. The descendants of those survivors spread eventually across every continent except Antarctica. They developed agriculture and metallurgy and writing in cities and spacecraft. They produced every piece of music ever composed and every mathematical proof ever written and every meal ever cooked in a kitchen with reliable electricity. All of it traces back to a few thousand people who managed to keep their fires lit. The specific number that researchers have arrived at for the minimum viable ancestral population varies depending on the methodology and the genetic markers being analyzed, but the most rigorous estimates cluster around 10,000 breeding individuals as the floor, with some analyses suggesting the effective population dropped even lower at certain points. For context, 10,000 breeding adults represents a total population, including children, elderly, and non-reproducing adults, of perhaps 30 to 60,000 people. Spread that across an entire continent, and you get densities so low that a person could walk for days without encountering another human being. Low enough that some groups were genuinely isolated for generations, seeing no outsiders, having no context for what lay beyond the limits of their own territory. That isolation shaped everything about how those groups perceived the world. The cognitive anthropology of extreme isolation is one of the stranger corners of research into early human populations. Groups that maintained contact with other groups through trade, intermarriage, or seasonal aggregations consistently show broader symbolic vocabularies, more complex tool traditions, and more extensive exploitation of diverse resource types than groups that lost those connections. The exchange of people, ideas, and objects between groups functioned as a kind of cultural immune system. New knowledge entered through new people. New techniques arrived through traded objects. New ways of solving old problems diffused across networks of connected groups in ways that genuinely expanded the toolkit available to everyone in the network. Groups that fell out of those networks became cognitively as well as genetically vulnerable. This is something modern humans still do in diminished forms. The social networks that allow ideas to circulate, the institutions that aggregate knowledge across individuals and make it durable, the educational systems that transmit accumulated understanding across generations. These are elaborated versions of the same functions that were already operating at small scale and high stakes. 100,000 years ago, around campfires in Eastern Africa, the campfire was the first network node. One aspect of this period that deserves more attention than it typically receives is the role of disease. Modern forager populations, even those living in relatively isolated circumstances, are exposed to a wide range of pathogens that they have developed some immunity to through exposure and natural selection over generations. But a small isolated group encountering a novel pathogen for the first time has no such immunity. The catastrophic mortality events that decimated isolated indigenous populations when they first encountered European diseases in the post-Columbian period were not unique to that moment in history. The same dynamic almost certainly played out repeatedly during the deep prehistory of Homo sapiens, a group that had been isolated enough to lose immunity to a particular pathogen, then encountered that pathogen through contact with another group, could be devastated within a single season. Some of the gaps in the archaeological record are probably exactly that. A group of people who were healthy and functioning one generation becomes invisible to the fossil record in the next, not because the climate failed them or the predators overwhelmed them, but because something microscopic moved through the camp and the group did not have the biological defenses to stop it. The survivors, if any, either joined neighboring groups where they would genetically dissolve into a larger population, or died alone, leaving no descendants and no record, except the faint presence of a particular genetic variant that would later show up in a laboratory analysis thousands of centuries after the fact. The full picture of human life 100,000 years ago is not one of primitive simplicity. It is one of enormous cognitive sophistication operating under conditions of extreme material constraint. The people alive in that period were fully modern humans in terms of brain architecture and almost certainly in terms of language capacity. They could plan, remember, imagine, grieve, celebrate, argue, and create. They had inside jokes and favorite places and deep knowledge of specific patches of landscape that they had spent their lives learning to read. They had opinions about the best way to make a particular tool and disputes about who was supposed to watch the children during a particular hunt, and elders whose stories held the group's history in living memory. They were completely recognizably human. They just existed at a scale that left almost nothing behind. The transition out of this period of maximum vulnerability into the eventual expansion that carried Homo sapiens across the planet was not a single event or a single invention. It was probably a gradual accumulation of small advantages, better networks, more resilient social structures, slightly more efficient exploitation of coastal and riverine environments, the slow diffusion of symbolic technologies that made knowledge more transferable and more durable. The genetic evidence suggests that the population began recovering somewhere around 70 to 80,000 years ago, following the worst of the Toba-related climatic disruption, and that the recovery once it began was relatively rapid on geological timescales, though still spanning thousands of human generations. By 60,000 years ago, something had shifted. The populations that would eventually leave Africa and populate the rest of the planet were assembling along the corridors that led north and east. The genetic diversity visible in living non-African populations suggests they all descend from a group that was perhaps only a few thousand individuals strong when it finally made the crossing, narrow enough that the founder effect compressed the genetic variation it carried into a fraction of what remained in Africa. The people who left were the offspring of survivors. Every instinct they carried had been filtered through the crucible of the preceding 40,000 years. There is something that genuinely stays with me about this period, and I say that having spent a significant amount of time with the research. It is not the scale of the threat, though the scale is staggering. It is the persistence, generation after generation, in circumstances where giving up, where simply failing to invest in children or maintain group cohesion or continue the daily exhausting work of survival would have been so much easier than continuing. And yet those people continued. They kept their fires. They kept their children alive. They kept moving when they had to move and staying when staying was viable. They maintained the social bonds that made collective action possible, even when resources were so scarce that defection, taking more than your share and leaving others to manage the shortfall, would have been individually advantageous. They were cooperative under pressure in a way that their descendants, living in abundance by comparison, sometimes struggle to manage. Every human alive today carries that inheritance in their genome, a direct biological line back to people who survived the worst sustained environmental crisis their species had ever faced. The specific adaptations that made survival possible, the social cognition, the linguistic complexity, the symbolic thinking, the flexibility in the face of environmental change did not appear after this crisis as a response to it. They were already present, already being built into the species through the preceding 100,000 years of evolution, and they were precisely the right tools for exactly this catastrophic moment. The species had been building the equipment it needed without knowing it would need it. That is either the most remarkable coincidence in the history of life on this planet, or it is a reminder that the pressures that shaped human cognition were never gentle ones. The brain that can compose music and build telescopes and write philosophical treatises was forged in a world where those capacities were secondary benefits of cognitive architecture that existed primarily to keep a small group of people alive through another season in a landscape that was actively trying to kill them. We are the children of that struggle, every one of us. If you made it to the end of this, you are exactly the kind of person this channel exists for. Leave a comment with where you are watching from and what you would most want to see us cover next. The periods immediately after this one, the expansion out of Africa, the first encounters with Neanderthals, the peopling of the Arabian Peninsula, are all in the production queue. Subscribe and turn on notifications so you catch them when they drop. The next video might be the most important one we have made yet.